Hi, guys. All right. So we're going to do notes a little bit differently this time. You are still going to be filling it in as we go. You can pause this video as much as you need to in order to fill in everything. But the best part, you should have a highlighter because I am going to be telling you very specific things that you need to study for your test that will be on Friday. So press pause so you can get that highlighter. If you don't, that's on you. Here we go. So, atmosphere. It is the layer of gases that surround the Earth. Its purpose is to support life on Earth by protecting it from dangerous electromagnetic radiation. Creates and controls weather and climate and provides gases plants and animals needs to breathe. Okay, in this section, you're going to want to highlight this right here and try to remember all of these three things because this is going to be a part 2 question. Part 2 questions require you to do some writing. So this entire thing is going to be something good for you to highlight. Don't forget, if you need to press pause or go back, please do so. I'm going to keep going though. Next section, maybe. Whoops. Okay, composition of the atmosphere. You're going to want to highlight this. There will be a multiple choice question that asks you something about the composition of the atmosphere. Nitrogen is 78%. Notice on your notes, you don't see any red boxes on this screen coming up, but there's a whole bunch of blanks. So you're going to want to press pause, copy that information. 78% nitrogen, 21% oxygen, 0.90% argon, and 0.03% carbon dioxide. Everything else is very minute, 0.17% other trace gases like neon, methane, krypton, and hydrogen. All right. Next section. Our atmosphere. These are the gases that are important to life. Oops, wait a minute here. Let me go back. No, that's right. Okay. The gases that are important to life. Nitrogen. Whoops. Removed from the atmosphere by bacteria and lightning. Nitrogen compounds used by plants in growth and development. You've got oxygen, which is released into the atmosphere by plants as they photosynthesize. I would highlight this right here. You will have a question about that. Water vapor. Amount varies in the atmosphere, cycles through the hydraulic water cycle, and carbon dioxide is removed from the atmosphere by green plants. This is the other section that you're going to want to go ahead and highlight. So both of these sections right here are going to be on your test. Atmosphere pressure. Pressure exerted on the earth by the atmosphere. This decreases with increased altitude. In other words, pressure decreases as you go up. 14.7 pounds per square inch at sea level. So things that you'd like to know here. This section right here, highlight that. Atmospheric pressure decreases with increased altitude. So the higher you go up, the less the pressure is. And this lovely number right here, you're going to want to memorize as well. Now, the next part, you have a question. It says, does the thermosphere or troposphere have the greatest atmospheric pressure? Well, based on what we just said, here is the troposphere. Here is the thermosphere. And it says it decreases with altitude. So what can you assume has the greatest pressure? Here you go. Whoops. The troposphere has the greatest atmospheric pressure. Again, that's down here. And we know that as you go up, the atmospheric pressure decreases. So please write this where it says question on those 3 lines that are on your paper. Atmospheric density. At greater altitudes, the same volume contains fewer molecules of gases. It's measured with a barometer. You know this. This is something that we've learned way back in the beginning when we were doing our atmosphere. So you just have those 3 blanks to fill in. Your question that you need to fill in, we're going to compare the volume of molecules at Earth's surface and far above Earth's surface. So you're going to want to press pause and copy this on those 3 lines. At Earth's surface, the atmosphere is much more dense. There are many particles in a small area. Far from Earth's surface, it only has a few particles in a small area and is so much less dense. That kind of makes sense, right? Because in the last slide we just said the atmospheric pressure is greater closer to Earth and it decreases as it goes up. So this kind of correlates with that positively. Make sure you press pause to get that. Atmospheric warming, and I'm going to be honest with you, you're going to want to highlight this entire section. Solar radiation. You will have questions about solar radiation. 49% is absorbed by Earth's surface. 20% is reflected back by clouds. 20% absorbed by atmosphere and clouds. 6% is scattered by the atmosphere, and 5% is reflected by the Earth's surface. And your question, what percentage of solar radiation reaches the Earth's surface? 54% of solar radiation reaches the Earth's surface. So make sure you copy that down. So in other words, where that 54% comes from is right here. 49% is absorbed and 5% is reflected by the Earth's surface. It still reaches the surface. It's just not that it's absorbed. So that's 49 plus 5 is the 54%. Layers of the atmosphere. Now, you guys have had a lot of experience with this with our centers. The layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Those are the ones that you want to make sure you know for sure. So please make sure you highlight all of this. You are going to have to know the order of them from highest to lowest and lowest to highest. So make sure you have it memorized. And your question, the ozone layer is between what 2 layers of atmosphere? That would be the ozone is between the stratosphere and the mesosphere, which you guys should have learned that from your centers. So, and on your notes as you're copying it down, you have that diagram that's there too, but this one should be pretty simple for you. Pause if you need to, don't forget. Next, our layer boundaries. Let me make sure I have everything highlighted here for you. Whoops. The differences in temperatures separate each layer from the next. Follow the red line to see the temperature in each layer. So this is the red line that you're following. And here is the different temperatures. So you will see how that that red line correlates. Temperature remains constant through boundary. And the boundaries are the tropopause, the stratopause, and the mesopause. Now we're going to get into our individual layers. So the troposphere is the lowest layer. It has the most atmospheric air that's found here. It extends from 0 to 14 kilometers, which is 9 miles above Earth. Air temperature decreases with height above Earth, which we've already learned. Virtually all weather occurs here. So this is a nice little diagram. You're going to want to make sure you know the troposphere. And our question, as you get higher in the troposphere, what happens to the temperature? And I have it over here for you. Please make sure you write it down. The higher in the troposphere, the colder the air. Which kind of makes sense if you think about it, because this is what's closest to Earth. And think about mountains. When you climb mountains, it gets colder as you go up. Weather in the troposphere. This is going to be a part 2 question. Make sure you highlight everything you're about to see here. So weather in the troposphere. is the wind. It's caused by unequal heating of the Earth's surface. Whoops, my bad, going back. Okay, so make sure you kind of take a look at these pictures that are here. Now, I did not put these in your notes, and that's okay because this is the most important part here. Weather in the troposphere, water vapor. The moisture moves through the water cycle. Surface water is heated by the sun to start evaporating, then condenses and precipitates. Humidity depends on the amount of water vapor in the air and air temperature, which we did learn when we were doing our other centers. Dew point, temperature at which water begins to accumulate on surface, condenses. So you're going to want to make sure you know this word, dew point, all of these things. The next part is the question, what is the water cycle? You've already learned this, but here you go. Let's put a nice big one here. Copy this down. The water cycle is how water travels through Earth and the atmosphere. It includes evaporation, condensation, and precipitation. Press pause to make sure you have this. Moving on to clouds. So, our four main types of clouds. Now, when you were doing your centers, you had lots of different types of clouds, but there's four main types, and these are the four that you're going to need to make sure you know for a part 2 question. So, cirrus, it is the high level, wispy, curly, composed of ice crystals. So if you look over here, here's your cirrus. This is where your ice crystals form. Cumulus. So our next type is our cumulus. They're mid-level right here. They're fluffy, dense, mostly composed of water droplets. Our stratus down here, those are our low level layers like a blanket composed of water droplets, and you can kind of see it almost looks like foggy. And our nimbus extends through all levels, rain and storm. So you have nimbostratus, you see nimbus in this word here, these are our altocumulus, and our cirrostratus up here. So make sure you memorize these four and a couple of characteristics. This will be a part 2 question. Next is our stratosphere. All right. Oops. So the air temperature increases with the height above Earth due to the ozone absorption of sunlight. It's 14 kilometers to 50 kilometers above Earth. It's very common. It allows for undisturbed flight. So that's where you see if you've ever flown in a plane before, you get through the clouds, and all of a sudden you're up on top of the clouds. That's the stratosphere. The ozone layer is found near the bottom of the stratosphere. And our question, as you get higher in the stratosphere, what happens to the temperature? Oops. As you get higher, the temperature actually increases. After you finish filling that in, you're going to go on to the next page in your notes where we talk about the ozone layer. Here we go. Oops. Okay, so our ozone layer, this is going to be a part 2 question. So you're going to want to really review about ozones. Ozone gas, which is O3, absorbs solar radiation. It releases it as heat, protects the earth from harmful UV rays. That's why we don't get skin cancer every time we go into the sun, because the ozone layer protects us. Ozone can be good or bad at different altitudes. Okay, comparing the good and the bad zone. So I made this a little bit big for you. Good ozone is found in the stratosphere and mid-troposphere. In the stratosphere, ozone absorbs harmful UV light. In the mid-troposphere, ozone destroys pollutants. Bad ozone is found at the top and bottom of the troposphere. At the top, ozone traps heat near Earth. At the bottom, ozone creates smog. Please press pause right now to finish copying this. Our next layer is the mesosphere. It is 50 kilometers to 80 kilometers. Air temperature decreases with the height above Earth. It is the coldest layer. It protects Earth from meteorites. I can't say that word. And usually burns up in this layer. So here's what you need to know. You need to know that this is the coldest layer. Please highlight that. You need to know that it protects the Earth from the somebody say that word for me. I can't say it. I don't know why I can't say it. Meteoroids. There it is. Meteoroids. Good grief. Okay. You need to know those two things. Make sure you highlight it. As you get higher in the mesosphere, what happens to the temperature? Well, we already know it. The mesosphere burns up meteoroids that enter the Earth's atmosphere, protecting the Earth. And we already said up here, air temperature decreases with height above Earth. All right, thermosphere is the heat sphere. You need to know that it's the heat sphere. It's 80 kilometers out into space. The temperature increases with height above Earth, 1,800 degrees Celsius to 3,300 degrees Fahrenheit. That's crazy. The aurora borealis, which is this right here, the northern lights, that's where that happens. The space shuttles orbit here. And the ionosphere is the lower part. The exosphere is the upper part. So these three, 1, 2, 3, these bullets, this is what you need to know. The space shuttles, the ionosphere, and the exosphere. As you get higher in the thermosphere, what happens to the temperature? Well, the temperature increases. So as you get higher in the thermosphere, the temperature increases. Please make sure you write that down. All right. Next section, ionosphere. It included in mesosphere and thermosphere. Gas particles absorb ultraviolet and X-ray radiation from the sun. Particles become electrically charged ions, which you remember. I don't know if you remember this, but this has been forever. We learned about ions way back when we were doing elements. Radio waves are bounced off the ions and reflect back to Earth. You do need to know a lot of things from this slide, so I would highlight a lot. Now, part 2 question is going to be something like this. How does the ionosphere enable us to listen to radio? This is going to be something you really want to pay attention to because this is a part 2. Radio waves travel into the ionosphere and bounce off of the charged particles in the ionosphere, bouncing back towards Earth. They travel to different locations on Earth, letting us listen to signals not near us. Yeah, write all that down. Moving on to the exosphere, it is 550 kilometers, thousands of kilometers into space. So it's huge. The air is very thin. GPS satellites orbit the Earth here. Our question, what causes the exosphere to have very low atmospheric density? Here is what I want you to copy. Whoops. Here we go. Since the air is very thin, there are not many particles in a given space, so the density is low. And if you remember back in one of our earlier slides, we saw the diagram that showed the density thinning out as it got higher up into space. All right, our final section, beyond the atmosphere, the magnetosphere. Now, I will be honest with you, you're not going to have a question about most of this. There is one section you're going to have a question about. So the magnetosphere, it's Earth's magnetic field about 1,000 kilometers above the Earth's surface. It traps harmful particles from the sun. What you're going to want to pay attention to is this Van Allen radiation belt. So particles concentrate into belts or layers called the Van Allen radiation belts. It causes the aurora borealis in the upper atmosphere. All right. Oops. Where is the magnetosphere located? Outside of Earth's atmosphere. So really make sure you pay attention to the Van Allen belts. Okay, you now have all of your information. Don't forget, if you missed something, please go back and find out what you need to plug in. This is going to be your study guide. You will be doing a review activity and then taking your test on Friday.